Hello everyone, myself Vinay Kumaram. I'm actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was actually explaining what is matter and how matter is made up of particles, and I also explained what are all the different characteristics of particle. So in this particular video, we will be learning different types of matters. So matter is classified into three different types. One is the solids, the other is liquids, and the third kind of division of this particular matter is gases. So this is actually three divisions of matter, and these are known as state of matters. So all these three are actually known as state of a particular matter. So what do you mean by state? In what particular state, in what particular position that particular matter is. So either the matter can be in solid state, or the matter can be in liquid state, or the same matter can be in gaseous state as well. So for example, if you take ice, so ice cube is actually an example for solid. So the same ice cube, when it is brought out from a refrigerator, so you can see that particular ice cube will melt into water. So that means matter is converting into liquid state. The same matter is converting into liquid state. Now, if you actually boil that particular water, it will evaporate. When you actually keep your hand upside a boiling water, you can feel that particular steam which is hitting your palms, and you can see small water droplets on your palms. That means water from the container is escaping in the form of gas. That means the same matter is now converted to gaseous state. So we will learn what are all these three states. So the first state we will actually discuss, that is the solid state. So any object which are having a proper definite boundaries, definite wall, and which are rigid in nature are known as solids. So here you can take a particular table, or you can take a particular iron nail, or you can take a particular bottle, plastic bottle, or any kind of solid objects. When you take, you can easily see they don't change their shape very easily. Only when you apply certain amount of force, the external force, they will change their shape only when the necessary force is larger and which is capable of changing their shape. That shows solids have definite boundaries. So you should remember, solids have definite boundaries, and this particular solids are rigid in nature because they easily don't change their shape. So now you can have a doubt that sugar crystals in a particular jar. So in whichever jar you put this particular sugar crystals, they take different shape. So that doesn't mean sugars are not solid particles. They are also solid particles, but they are actually divided into smaller particles. So the each individual solid crystal is a solid material. So that's why sugar is also an example for solid particle. So now you can have doubt about a rubber band. So rubber band also changes its shape, but it doesn't changes its shape just like that. Only when you actually apply external force for that particular rubber band, then only it will change its state. And when you stop applying external force, it will come back to its original shape. That also shows this particular rubber band also have a certain amount of shape and certain amount of definite boundaries. So this particular rubber band is also an example for solids. So now you can actually think about sponge. So let us say you have a sponge like this, a square or a rectangular sponge, and this particular sponge will be having lot of holes in it. So this particular sponge can be easily compressed. So here the shape of this particular sponge is easily changing. So can we consider this as liquid or gas? No, because the holes which were there in that particular sponge has occupied with air molecules. So when you actually compress this particular sponge, the air molecules which are trapped in that particular holes of sponge gets escaped, and hence the shape of sponge changes. But when all the holes which are there in the particular sponge is removed, then that particular sponge cannot be compressed further. So when you compress sponge to a certain extent, only to a certain extent it can be compressed. After that it cannot be compressed. That means there is no more air molecules which are present inside that sponge which are getting escaped. So Here also you can clearly see the sponge is also made up of certain boundaries, and this particular sponge also have definite shape. This particular sponge is also having certain definite boundaries. So sponge can also considered as a solid. So the main thing which you should remember here is that particles inside a solids will not have greater random motion. So the particles inside this particular solid object, so let's say this is a particular solid object which is made up of particles. So this particular particles have very less space to move across the matter. So all these particular particles will be fixed in one particular position and they don't move from one place to other place. So a particle which is lying in this particular position will not move to this particular position, and particle which is lying in this particular position will not move to this particular position. So there is no inter-traveling of particles inside the matter because particles are very much tightly bound inside the solids. So that's why this particular particles will have greater amount of intermolecular forces which are binding them into a definite shape, definite volume. So that's why solids are very hard and rigid and very much difficult to break them into particles. Coming to the next state, that is the liquid state. Here liquids doesn't have a particular definite shape. So in liquid, if you take example of water, you can see if you put water in a square bucket like this or in a rectangular bucket like this, the shape of water remains rectangular. If you put the same amount of water in a circular shaped container, you will see that water is having circular shape. So if you take a particular pyramidal shaped container and if you fill water in this, so there also you can see that particular water is having the shape of that particular container. So wherever you put water, whatever the shape of container is, that particular shape, that particular water will take. So that means the particles inside liquid have lot of spaces in between them. So coming to the solid state, the space in between particles is very less. So that's why this particular particles cannot move from one place to another place. But when it comes to liquids, particles will be having lot of space in between because of lot of space presence in this particular liquid state matter. So this particle will move throughout the solution. A particular water molecule in this particular position can move to this particular position, and a particle in this particular position can move to this particular position, or these particles which are there in this particular liquid state or in this particular water can move across the matter because there will be lot of space present in this particular water. Hence, water or any kind of liquid solutions cannot have a definite shape. They take the shape of the container. So that's why the random motion of particles inside these particular liquids will be more because there will be more space availability in between the particles. Hence, these particles can easily move throughout the solution. So properties, coming to the properties of this particular liquids, these particular particles have lot of empty space. Particles have empty space in between. So there will be lot of empty space in between particles compared to solid objects, and also this particular particles will have greater kinetic energy compared to solids because this particular particles will have lot of empty spaces in between. Hence they can possess more kinetic energy and they can randomly move throughout the matter. So that's why they don't have proper shape. So here in liquids there is no definite shape, and also this particular liquids, the random motion of particle is more. So because this particular random motion of particles inside liquid is more, this particular particles will have greater kinetic energy. So this second point and fourth point are interconnected because random motion of particles are more in this particular liquids, they possess greater kinetic energy. So the second and fourth point you can actually have an interconnection. So coming to the next state of matter, that is the gaseous state or the gases. So gases have much more higher random motion because now the particles which are there in this particular gaseous state matter, so here particles will be having lot of space in between. So if you take solids, particles are very much tightly bound with each other, hence they possess definite shape and volume. But in liquids, there will be lot of space in between particles, hence they can move throughout the matter, and hence they have like more kinetic energy, and they can randomly move around the matter, around the solution. So here in gaseous state, there will be much more larger space in between these particles, hence these particles are free to move throughout the atmosphere which is there around us. So that's why gases can move anywhere, because of its lot of space presence between particles. So hence here gaseous molecules also cannot have a particular definite shape, and they cannot have a very good intermolecular forces, because in solid there will be more intermolecular forces, hence particles will be bound with each other. But in gaseous state, the molecular force between the particles will be very less, and hence those particles will be moving around the atmosphere. So in exam, if they ask you to tell the difference between solid, liquid and gases, you can give all these points and you can actually make a comparison between liquid state, gaseous state and the solid state. So, and one more thing which you should remember in this particular gaseous state is that because of availability of lot of free space between particles, this particular particles will be having very high random motion, and because of very high random motion, they possess larger kinetic energy compared to liquids as well. So greater will be the kinetic energy in gases compared to liquids and solids, because particles in gaseous state will be having lot of space in between, and they can easily move around the atmosphere with greater motion. Because of that, they gain more and more kinetic energy. So now let us take a particular solid state object. So let us take a particular cube. So particles are very much tightly bound in this particular cube. So hence the particles inside this particular cube will be having lesser amount of kinetic energy, and hence they exert less amount of pressure on the walls of this outer boundaries of this particular cube. So the outer boundaries of that particular cube or the particular container will experience less pressure, because particles inside that particular cube will be having less amount of kinetic energy because it is in the state of solid. Now when it comes to water in a bucket, here water molecules will have greater amount of kinetic energy compared to solid particles. So the particles inside water will have greater kinetic energy, and they will hit this particular walls of container. So let us take the wall of this bucket as walls of container. So this particular wall of container experience more amount of pressure by the water molecules present in that particular container. So now if you take a balloon and if you blow air into that particular balloon and close it, here also this particular balloon will be having lot of pressure inside, because kinetic energy of gaseous molecules, because the air which you are blowing is actually in the state of gas. So that means this particular gaseous molecules or the particles which are in gaseous state will be having more space in between, and hence there will be more random motion. Because of more random motion, these particular particles will have greater kinetic energy. Because of greater kinetic energy, they exert lot of force on this container. So if you consider this as the wall of container or the wall of this particular balloon, this particular particle which is there inside this balloon will be having greater kinetic energy, and with greater kinetic energy it will be hitting this particular wall of this particular balloon. Hence the external surface of this balloon will experience more and more pressure. So this is all there in this particular video. If you want to learn more physics, chemistry and mathematics related to 8th standard, 9th standard, 10th standard, then you should subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.